Hi guys, welcome back to our Trig Substitution integrals summary. After all these 10 classes, I think about 10 classes, we discussed too many cases, how we use the trig substitution in our problem, how we use sine and cosine, tan, secant, and when we can use it. Today I will summarize everything for you and I will try to make it easy. But you have to understand, some of the teachers, they want to see the work. They want to see the substitution. They want to see how you apply the trig substitution into the problem. They like to see all the steps. Some of the teachers, they don't care. They said we need the answer. When it's open-ended, you have to show all the work. Because that, even when I summarize all these trig substitution, I insist to make it as it's an open-ended. Let us see what I have. First thing, if you have any question, all what you have to do, just contact us, call me at this phone number, and send an email to this email. Okay. And our class is about techniques of integration, summary of trigonometric substitution, integrals. If you like it, subscribe, please. If you don't like, we try. At least we try. At least we try. If you like it, subscribe. If you don't like, we try to help you as much we can. Okay. Now trigonometric. Okay. The first case we did. This is the first case. D over. Look here. A squared minus x squared. Remember these cases. Remember. Then this D is constant. D is what? D is constant. D is constant. Right? D is constant. You can leave it out. D over B sine inverse B over A, right? And my trig substitution will be A over B sine theta. And if you solve for sine theta, equal. And the associated triangle, you have to have a triangle, a graph here, like this, triangle. And okay, the angle theta here, and the sine bx over bx over bx over a, right? On the hypotenuse A, and this guy, and this guy, okay, and here, sorry guys, bx over, and this one is a squared minus b squared x squared. Example here, quickly example. Look here, negative. Let me just take a different color. Just arrange. Let me just take this color. Okay, integration of negative 3 over 25. Anything has, okay, 3x squared dx, negative 3 over b, which is square 3. B is what? Okay, b square root of 3. You see that? b is square root of 3, because a square equals 25, a equals 5, and b square equals 3, b equals square root of 3. I meant to have this one, sine inverse b squared 3 over 5 x plus c. That's quickly. And the same thing for here, negative 3. And your substitution is what? X equal 5 over 8 sine theta equal 8 over 5x. Then negative 3 over 8 sine inverse 8 over 5x plus c. Just applying this rule. I think this is very clear quickly. You see, that's my example, negative 3 over b, which is square root of 3. And sine inverse always b, which is square root of 3 over 5x plus c. Good job. Okay. Now, the difference between this case and the second case, you see here and this here, the difference between here and here, if you want me to enlarge it a little bit to make it, to see what I did, this one, and this one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is the example, negative 3 here, over 3, and okay, good. Now what's the difference between this and this? This is in the numerator and this in the denominator, but the same trig substitution we're going to use, a over b, sine theta for x, and sine theta, and the same triangle we're going to use. Now, but here is a long one, sine inverse dA squared 2b sine inverse b over ax. I think it's easier to apply go back to my videos and apply the substitution and solve. But if you like this way, it's up to you. I will not memorize this one, it's a little harder. Some students, they like to have it done in it. In this case, my d is 3. My d is 3, right? My d is 3, and my a is 3 also from 9. My b is 4, then 3, 2 times 2b, 2 times b, not b squared, 2 times b. Okay, this is 2 times b. Okay, now, and here 3 times 9, 2 times b is, b is 4 is 8. Okay. And you apply the formula, half sine 2 sine inverse xb over a. But believe me, for this case, no problem, but go back to my notes and see how I solve this problem completely. If you need me to solve more problem like this, just send me an email, tell me in your table the second case of the sine inverse. Can you please solve problem? I will solve more problem about this. But this today class is to show you the common integrals. This is the first case for the tan, and then when we have minus, we use sine. When we have plus, we use tan, right? Then a, and the same thing. You can finish this one. We can finish this one. And solve the problem. We can graph. If you solve this for tan theta equal bx over a, and all of us know tan is opposite over adjacent, and theta here bx over a, and this will be what? Square root of what? b x squared plus a squared, b squared x squared, and d over b, d over a times b, d over a times b, tan inverse. Okay, example. I have example and I have another one. 5 over 3 over 9x squared dx. You leave the 5, which is the d. A squared 3, because a squared equals 3. Then a equals square 3. B squared equals 9. B equals 3. Right? 3 squared 3 and what? B is 3. Tan inverse of b over a, 3 over a is square 3. Okay, tan inverse 3 plus x plus c. And there's another example there. 3 over 20, look here. What's your triangle here? See your triangle here. X equal tan, then tan theta equal 5x over 2, and theta 5x and 2, and here square root of 4 plus 25x squared. Okay, applying the rule D, which is 3, 2 times 5, tan inverse 5 over 2x. Good job, plus C. Good job. Okay. Okay. Now look at the difference, and I meant to have each case in two. Look here. When we have no square root and we have, since I have a plus b squared plus x squared plus bx squared, I have square root, I have no square root. I have the same trig substitution. I have the same, look here, the same trig substitution. X equal a over b tan theta. But if we have no square root, if you have no square root, and the equation is easy, tan inverse b over ax, which is all these constant, a times b. Okay. Here in this case, if you have no square root, if you have square root, look, this is the general form. D now I solve problem like that. If you need me to solve more, just let me know and email me or text me on the phone number at the back to the front of the video, the beginning of the video, this video, and you will see the phone number and well. Okay. Now then d over b ln tan theta plus secant theta, and remember the triangle, you have theta here and theta equal bx over a, and this here, and here, sorry, bx, b squared, x squared plus a squared. Look here, I need to show you theta equal tan inverse of b, right? Theta equal, tan theta, I mean, if you go to tan theta here, bx, look here, tan theta is what? To know how I got this one, tan theta equal bx over a, right? Tan theta equal bx. Okay, tan theta, back. Okay, this one, tan theta equal ba over x, right? Bx over a, which is this true. The secant is the secant. To find the secant theta, you have to find cosine theta first. Find cosine theta. Cosine theta equal adjacent over the hypotenuse, b squared, b squared b squared x squared and a squared, this a squared, which is what we have here. Now you flip it, because secant is 1 over what? Secant is 1 over cosine theta. Okay. Now an example for that, let us see, d is what? -5, a is 3, b is 4, and my substitution is x equal 3 over 4 tan theta. Okay, then tan theta 4 over 3, then negative 5 tan theta, which is 4 over 3x. Okay, remember this one over, okay, 9, the same as this one. Okay, good. I'm going to leave this for a few minutes for you. 1 minute, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just see it. See what we have. If you want to copy. Okay. Now, the last case, which is the secant. Now, this case, I need this, I put this, I add this. Look here, bx squared minus a squared. Okay. The formula, d over b, ln tan secant inverse b over a plus secant inverse. Okay. Now, this are easier to memorize. D over b, d is the constant, b squared x squared minus a squared, which is the denominator, over a plus ba over x. Okay. Or you can write some book, they will write it like this: d over b, ln, they put 1a because the same denominator, b squared x squared minus a squared plus bx. Okay, whatever you want. You can choose this way or that way. Now, the same thing here. A is 9. Good. Then a squared is 9. A squared is 9. A 3. B squared is 25. B is 5. Okay. Then x equal 3 over 5 secant theta secant 5 over 3 cosine theta negative 2 ln tan secant inverse. If the teacher wants you to have it in this form, always don't forget to have the c ready. And this is this form. Okay. 1 second. Then remember this form when we have bx squared comes first. When bx squared comes first, that means you have to use the secant, and this is your trig substitution. X equal a over b cosine, secant theta. X equal a over b secant theta. The last case, which is the hard case. Look the difference. This and this are the same. Look guys, this and this the same, but this is in the numerator, in the denominator, and this in numerator. It's not easy for the teachers to get these problems for the kids. It's not easy for them to get see these type of problems for the kids, for the students, because it's hard substitution. It's easy to use the trig substitution and follow the direction, and remember always, as I said, you have to remember always that ln, right? You see this guy? Ln secant theta integration of, you see this guy? Remember this guy all the time. Remember this guy all the time. This one, this guy. Okay. And this is what you have to remember. I don't want to focus a lot on this case. I'm going to leave it in the board for 1 minute for you, just to look at it. Okay, this is the format you have to remember. And there's a way, bx, and the same thing as we have here, the original integral given for both, bx, but here multiplication, here addition, and here we divide by a, here multiply by a squared. Then you can find your way to do this. And this is, wow, this is an example. D is 5, B is 9, B is, which is here, you see that? B 3, A is 4, and my substitution, trig x equal 4 over 3. Now, apply all these numbers into their formula here. Okay. Guys, thank you. Have a nice day. Be safe. And you are more than welcome to send me any question about any topic you want. Thank you and have a nice day.